Okay, we are going to talk about probability and conditional probability, and we're going to probably do it in 2 videos just because it's going to be a little bit on the lengthy side. So we're really starting with probability right now. Probability is just the measure of how likely an event is going to occur. Typically, that probability is going to be, not typically, always 100% of the time. Your probability that an event is going to occur is going to be between 0 and 1, with 0 being that it is not likely at all, and like not possible, and 1 being that it's 100%, it's definitely going to happen. Usually we write it as a fraction or a decimal, sometimes as a percent. Now, sample space is the set of all possible outcomes. So when I use that, like if I'm rolling a die, the sample space is 1, 2, 3, 4, 5, 6. If I am picking a card from a deck of cards, there's 52 cards that I can pick from. So it's all of our possible outcomes that can happen. And what probability is, it's just a fraction ratio of our favorable outcomes. So the thing we're looking for, oh, I should mention, this means probability of event E. So favorable outcomes over total possible. So it's just going to give me that fraction. So let's look at some simple ones. And by simple, I mean just one thing is happening. So it says a card is drawn from a standard deck of cards. Find each probability. Now I'm going to show us the probabilities, but before I do that, let's look at what a standard deck of cards looks like. I realized a couple of years ago when I was working through some problems like this, there are some kids that don't know what a deck of cards look like. So this is a full deck of cards. There are 4 suits. We've got clubs, spades, hearts, and diamonds. Club and spades are both black suits. Hearts and diamonds are both red suits. You have the aces, and then you have your number cards 2 through 10. And then you have what's called your face cards, your jack, queen, and king. They're called face cards because guess what? They have faces on them. So that's how it is split up. So 52 cards, 4 suits, 13 cards in each suit. All right, so let's go back and look at these probabilities. So if I am looking for the probability that the card is red, so if you randomly select a card, the probability that the card is red is going to be 26 out of those 52, because it's the 13 hearts, the 13 diamonds, and then that's going to give you 1/2. You could have jumped right to 1/2 based on the picture that I just showed you, but if you're looking at total favorable, 26 of the cards are red. Out of total possible, there are 52 cards. Half of them are going to be that way. All right, the probability that it's a face card, so that's the jack, queen, and king of each suit. So there's 3 in each suit, 4 total suits, so that's 12 out of 52. And 12 out of 52, that reduces to 3 out of 13. Now, again, we could have jumped straight to 3 out of 13 because 3 in each suit are face cards, and there are 13 cards in each suit. And since they're equally spaced, that's what happens there. Okay. Now, what is the probability that it's not a face card? You know what I can do here? I can say all the other cards. So I can go 100% minus my 3 over 13, common denominator of 13, and do that subtraction, 10 out of 13. So I can take, if it's the not, it's called the complement, I can take and subtract it from the total possible for all the others. So 3 out of 13 are face cards, which means 10 out of 13 are not face cards. Okay, so that is our simple probability. Let's take a look at a slightly different one. So example 2, what is the probability that a queen is drawn given that a face card is drawn? So what I'm saying here in this part of this problem, I'm saying it was definitely a face card. So I am restricting my sample space here. I'm going to go back. I'll come back to it. So it says given that, okay, they keep making announcements. Sorry about that. So given that a face card is drawn. So that means that I am only looking at these 12. That's my new space, that's my new sample space. So if I want to know how many queens, what's the probability that a queen is drawn, given that it's a face card, I'm only going to look at those 12. So my denominator is now going to be 12, and there's 4 of them that are queens. So if I am looking at what is the probability that it is a queen, given that it's a face card, there are 12 face cards. So my new denominator is 12. 4 of them are queens. So 1/3 is that probability. And should make sense because 1/3 of the face cards are queens. Jack, queen, king, 1/3. Now what we just did there is called conditional probability. It's the probability that event B, the probability of event B occurring, knowing that event A has already occurred. So I'm going to give you some notation here. Probability of B given A. That's the way we say that. Probability of B given A. There is a formula, and I'm going to give it to you, but I'm not actually going to show you how to use it because we're doing that quick little probability unit, and we're going to use logic instead of the formula because I didn't show you how to do that part yet. But that is the formula. We would do probability of A and B happening divided by the probability of B happening. And what I'm going to do, since this video has gotten a little long, I'm going to do the examples in a separate video. So this is number 1, and we're going to do some additional examples in video number 2.